cloud data warehouse or data warehouse, anything is fine. So data warehouse means, so data warehouse is a type of a data warehouse that is hosted on a cloud computing platform. So cloud computing platform means, AWS, Azure, or GCP. So basically, this data warehouse is a large centralized repository of data that is used to support business intelligence, ad hoc analysis, and reporting activities. It is designed to store and manage large volume of structured, semi-structured, and sometimes unstructured data from various sources. I'll make it easier for you in a small points, I can say. For example, you all know about database. Database is what? Database is used for to store your data. Okay. So so this is a cloud data warehouse, but this MS SQL, Oracle, MySQL, all these things are what? These are all traditional databases, right? Traditional database means what? On-premise, on-prem. It is not a cloud basically. So if you want to store your data in MS SQL or Oracle or MySQL, we need to store the data in a hard disk basically, right? It's not like cloud-based thing. It's a complete hard disk or on-prem, on-premised one basically. On-premised means what? We need to store our data in a hard disk, right? So, for example, if you want to load millions of records in database, okay, you can store. There is no issue. But why do you need to store the data? So whenever you want, if there is any scenario that if there is any requirement is coming up from the client, okay, if you want to show some reports to the clients, like how the business is going on, whether it is in the profit level or in loss level or in neutral level. So how they are gonna see? By just using this reporting activities, right? By doing some ad hoc analysis, business intelligence tips, and they'll create the reports based on the data. But for example, if you want to if you want to show some report, so what we need to do, we need to fetch some data. We need to fetch that, right? From multiple tables, we need to fetch that. If you want to fetch the data, for example, 100 records in MS SQL, that is a normal traditional database. Now let's compare the Snowflake now. So Snowflake is there and MS SQL is there. Okay. So here, if you want to fetch some data, MS SQL or Oracle, anything is fine. If you want to fetch some data from Oracle for the 100 records, we can be able to get it easily. Let's say this time I want to fetch 100 million records now, this time from Oracle and also from the Snowflake as well. Okay. If you want to fetch that 100 million records, guys, for sure it will take you at least for 20 to 30 minutes. Sometimes depends upon the data. It will take minutes, maybe 20 minutes or 30 minutes. It's not a good practice. We need to get the data as early as possible. We need to fetch the data as early as possible. So, but in Snowflake, we can be able to get that information sometimes within a fraction, sometimes within minutes also, like 1 minute, 1.5 minutes, within seconds also, we can get sometimes. But we need to learn few things for that, to know about all these things clearly in Snowflake. So in this way, data warehouse, guys, we can do all these things. We can fetch the data, we can see the data, we can do the business intelligence tips, depends upon your business, depends upon your client requirements. We can do all these things, and we can do analysis. Ad hoc analysis means what? On priority based. Ad hoc means on priority based. We can also do the analysis and reporting activities. We can also create the reports as well. We can connect to Tableau, Power BI, all these things we can connect, and also we can create reporting activities as well. So here the major thing is we can store and manage large volumes of structured, semi-structured, and unstructured as well. But in normal traditional databases like Oracle, MySQL, in these databases, guys, we can store structured data. Okay, it is difficult to handle the semi-structured and unstructured, guys. In normal databases, it is difficult to handle semi-structured data and unstructured data. Structured means what? So, for example, if there is a customer table, customer information like a customer ID, customer name, their address, all these things in a tabular format. Okay, that is a structured data. When coming to semi-structured data like JSON, okay, JSON files and Avro files, Parquet files, XML files, all these things are semi-structured and unstructured. So these kind of structured data, like these kind of data files, like MS SQL, Oracle, it can't deal with those things, but Snowflake can deal with structured, unstructured, and semi-structured because Snowflake is a cloud data warehouse. Okay, and the data warehouse can deal all these things. And majorly this data warehouse will be useful for, if you want to store your historical information, for example, if you want to store your company's information from past 20 years, and based on 20 years data, if you want to predict something, if you want to if you want to see how the graph is going on for this from the past 20 years of my company. Okay, if you want to know, we can create some, Excel reports, or we can create Tableau reports or Power BI reports. By using that, we can be able to see whether this company is going in a profit level or in a, I can say in a loss level or neutral level. We can be able to see that. So by using this data warehouse, we can store historical information of multiple years. We can store our historical information maybe in a millions of records as well. But when coming to remaining traditional databases, we can do that, but it's not a performance. We will not see any kind of best performance, because it will take 20 minutes, 30 minutes to fetch the data only. So to store our historical information for our business purposes, okay, this data warehouse will be very, very useful, guys. And it can also deals with multiple files, multiple different file structures. So like I have mentioned before, but not normal database. It cannot deal with multiple types of multiple set of data files, like semi-structured and unstructured. It cannot deal with those things, basically, the normal database. So that is what all about data warehouse, guys. Okay, so that's why this Snowflake is a cloud data warehouse. And on top of this cloud, third-party cloud providers, that is AWS, Azure, and GCP, and it is fully managed by SaaS. What is SaaS? SaaS means software as a service. For example, if you want to use this MySQL or Oracle, all these things, guys, we need to install it first. Okay, we need to install all those things. We need to set up everything, like softwares or hardware. We need to install each and everything. Okay, but when coming to SaaS, guys, in Snowflake, we no need to install anything in Snowflake, guys. If you want to use a Snowflake, you no need to do any kind of installations, like it may be a software or hardware installations. We no need to do that. We need to create some account. Okay, we just need to log into it. That's it. That is called as software as a service. That is SaaS based. Let's just go to Google, type Snowflake, account creation. You can be able to give all your details regarding this account creation. We can create that, and by giving these credentials, we can be able to log into it. That's it. No need of any kind of hardware or software installation. So what we usually do for MySQL or Oracle, we don't need to do any kind of things, guys. So that is why it's very popular, basically. There are a lot of things in Snowflake when compared to the normal traditional databases like Oracle and MySQL and MySQL. There are a lot of differences and a lot of benefits, basically. So that's why nowadays each and every company or organization is moving to cloud, and particularly I can say proudly this they are moving to Snowflake, basically. Okay, and I'm gonna tell you so why they are particularly going for Snowflake. Even they have AWS, Azure as well. When compared to those things also, this Snowflake is performance wise and features wise, it's very, 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 very good. Okay, in all the point of like in all the ways, basically. So let's move on to the importance. If you can see the third point, importance here. So what is the Snowflake importance here? So pay-per-use model, which means Snowflake is follows pay-per-use model. Usually in normal databases, guys, if you want to store some data, we need to purchase the storage first. Along with compute power means to run your query, we need to buy some compute power as well. That is called compute, maybe a CPU cost, input output cost, all these things. 1 minute, guys. Okay. So pay-per-use model means, so usually we used to buy all these software constellation, softwares and storage, all these things. So we need to buy it before only. Okay. But when coming to Snowflake, we no need to buy anything before guys. Whatever you have used, you need to pay for that only. You no need to pay for any extra things, any extra storage. For example, if I'm using traditional databases like MySQL or Oracle, maybe in my organization, in this month, on monthly basis, we need to purchase basically. So this month, I'm expecting that it will gonna reach, it will gonna useful for almost 100 GB, for example. Okay, so 100 GB of storage I need to use for this month. That's what my assumption. Okay, but due to some situations, due to some scenarios, okay, I have used only 50 GB of storage only, and the remaining 50 GB of storage is empty. There is nothing is there. But you purchased it for 100 GB of storage. You purchased it, but you have used only 50 GB, and the remaining 50 GB is nothing is there. So we lost our money basically in such cases. But coming to Snowflake, guys, in the same situation, if you have used 50 GB of storage, you need to pay only for 50 GB, not for extra storage. Okay, that is why it is a pay per use model. So pay as you go model. So whatever you have used, so pay for that, not for the extra things. The second point, Snowflake is a powerful features and easy of use is challenging traditional data warehouses and solutions. So I already explained this point. Snowflake is having a wonderful features, and it is very easy to use. So that is why it is challenging the traditional databases and data warehouses like Oracle, MySQL, all these things. So that's why maybe you heard about these things. If anyone looking for Snowflake or some other things if they want to try to moving into cloud, they used to have this kind of word migration, project migration. So that's why all the projects nowadays in each and every company also, they are trying to migrate their project from on-premise to cloud. So on-premise means what? From Oracle or MySQL to cloud means what is this? Snowflake. They are migrating their project into Snowflake. So that's why it is, it is very, very popular. Okay. And Snowflake Cloud Native approach dynamic scaling, storage, and compute separation, challenging big data platforms too. And here, Snowflake is having, I already told you, it is having a wonderful features. And on top of that, it will also having, dynamic scaling, storage and compute separation challenging us. Storage and compute separation challenging, which means, guys, if you want to purchase something, purchase some storage in on-premise systems, I'm saying, if you want to purchase something, we need to buy this storage and the compute as well. So based on the storage, we need to buy this compute power as well. Compute power means what? If you want to run your queries in your SQL systems, we need to buy some compute power. Okay, based on the compute power only, we can be able to run that. And this coming to storage, which we need to store some data. Okay, these two things will be combined in normal on-premise databases, that is MySQL or Oracle. Okay, when coming to Snowflake, guys, these two are completely different. These two are the storage and compute cost will be completely independent, not dependent, because storage is storing the data in separate third-party clouds. So wherever you are hosted your account in Snowflake, maybe AWS or Azure or GCP, you can store your data over there. And coming to compute, okay, and coming to compute, we will get the compute power kind of some servers. So wherever you're, for example, I am hosted my account in AWS, so I will get the compute from AWS itself. Okay, these two are not dependent, guys. Okay, that is what they're trying to say. So because of these things, there are a lot of platforms, many platforms are nowadays also still this storage and compute things will be combined, not independent. Both are dependent. So that's why it is challenging this Snowflake is challenging the big data platforms too. Okay, and it will be very reliable. It will be very useful for this kind of domains like retail, finance, pharma, any kind of industrial things, everything, guys. Okay, that's why they are moving or migrating towards Snowflake as their platform of choice. Okay, and by looking at it, pricing competitiveness also, its unique architecture and a feature-rich ecosystem and it is make it, one of the most important technology to master. Okay, because of, we used to have few things in companies basically. They wanted to, if they want to do some project, they want to reduce the project amount, right? If they want to, buy some softwares, if they want to, work, if they want to complete the work, they need to buy some softwares, they need to do some work, right? For that also, they will try to reduce the pricing. So when compared to the remaining softwares and compared to the Snowflake, guys, it's very, 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 cost effective. Very very less cost, I can say. That is why this Snowflake is challenging even in the pricing point of view as well. Okay, for just example, I already explained you the storage things. So we need to buy for 100 GB of storage before only, but when coming to Snowflake, we need to pay only for what we have used. So in such cases, we already saved 50 GB of amount. With just an example, maybe it may be 50 TB also sometimes. So in such cases, we can save a lot of money as well. So that's why it is very, very, very reasonable cost. Even if you want to migrate from one system to into a Snowflake system, we can do a lot of things by using this one, guys. So that is why it's very popular, and Snowflake is very, very, very popular just because of this. One of the reason, because of this unique architecture, guys. Snowflake is also having some wonderful architecture. Okay, so that we're gonna see now. And Snowflake is having, three kinds of layers, guys. Database storage layer to store our data basically. In this layer, we can store our data. And coming to query processing layer. So whatever the queries we are running, okay, those queries will run in this query processing layer. Okay. And coming to cloud services. So cloud services is nothing but, guys, this cloud service layer is completely handled by Snowflake only. And what is happening in the cloud service layer? All the authentication access controls, infrastructure manager, and this optimizer, metadata manager, data security, account security, all these things will be handled by Snowflake only. We no need to do any kind of manual interruptions, guys. Everything will be handled by Snowflake only. This in the cloud service layer. Okay, so let's see one by one, guys. First one, database storage layer. When data is loaded into Snowflake, guys, Snowflake recognizes the data and it stores the data into columnar format. That is, hybrid columnar storage. So whenever you are storing the data into tables, okay, any of the from files to to load your data into Snowflake, guys, Snowflake tables, automatically this data will be loaded into Snowflake. Before that, the data got separated in a multiple micro partitions. Okay, so whenever you are trying to load your data into Snowflake tables, guys, before that, this data will be segregated into multiple micro partitions. Okay, in what format? Columnar format. Okay, your data got segregated into multiple micro partitions into columnar format. That is, hybrid columnar storage, guys. Okay, I will show you what is that. I will tell you as well. Okay, now see the example. For example, I want to load this file data into my Snowflake tables. Okay. But what we used to write, by using SQL commands, maybe, insert into table name, we will write values. So what are the values are there? We will insert those values into SQL tables. But whenever you're doing some loading some data into tables, guys, okay, this data, so while loading into table, these things will happen. If you see the physical structure here, these are called micro partitions, guys. Depends upon the data, these micro partitions will be created. For example, in this file, guys, okay, type, name, country, date is there, right? So this particular 24 records are got segregated into 4 micro partitions. Partition 1, partition 2, partition 3, partition 4. Let's see what is the use of these micro partitions and why it is creating why it is creating the data into micro partitions before going to load the data into tables. I will tell you these things now. Okay. So the use is, guys, whenever you are getting the data into tables, so In the back end, these things will happen. We won't be able to see it, guys, but in the back end, it will happen, basically. Okay, the Snowflake itself, it is handled. See, now see, for example, 243. Columnar, guys, remember, columnar format means the row level information will be able to see in a column level format. See, these are rows, right? Type, name, country, date. But now, how we can be able to see here? Type, name, country, date in the column level. So the row level format will be able to see in a column level format. So that is why it is called as, columnar format, guys. Okay. And how the data is stored? Now see. See, in the type, guys, 243, 232. See, 243, 232. First 6 records are inserted in this micropartition. And the next 6 records inserted into second micropartition. Third micropartition have 6 records. Fourth micropartition also having 6 records. Okay. Guys, remember, depends upon the data, these micropartitions will get segregated. It's not exactly 6 records only, but sometimes maybe 10 records, sometimes maybe 4 records. Depends upon the data, guys. Depends upon the data size. Okay. It will gonna segregate the data basically into micropartitions. Okay, so now see, for example, in normal SQL databases, if I want to run some queries, for example, select star from table name. If you want to see type 3 information, or else let's assume an employee table. In the employee table, I want to see employee ID 101 information. Okay, so what we need to write for that? Select star from employee table where ID equal to 104. Okay, let's assume employee table. Okay, we want to see some 104 ID information, employee information. So in such cases, what will happen? It will scan the entire table. It will scan the entire, it will try to search for 104 information, 104 employee information in that particular table, even if you have 1 lakh records in the table also. Even if you have 1 lakh records in the employee table, it will search each and every row, guys, to fetch the 104 ID information. Okay. To avoid that, so what will happen because of that? It will take some time to read each and every row, almost 1 lakh rows, right? We have in the employee table. So if you want to see that ID information, it will read every row by row. It will take some time, and cost-wise, it is very effective. It is very high basically. Okay, and time. Major thing is time. If you want to see the information, we need to wait for some time, even for simple queries also. Okay, but to avoid that in Snowflake, this concept as introduced for us, that is micropartitions. For example, if I want to see some type 4 information, see type 4 and name C information. Okay, select star from maybe it's a country table. Let's assume it is a country table. Select star from country table where type equal to 4 and name equal to C. By seeing it, we can be able to tell that in the micropartition 1 we have the data. Okay, so this Snowflake, what we will do is, it won't scan, it won't do any row by row operations, guys. It won't scan each and every record. It will directly go to this particular micropartition. Even if you search for type 2 and country UK, for example, if you want to see the information type 2 and the country UK, okay, it will directly go to this particular micropartition place. It won't do any kind of table scan. Table scan means each and every row by row scanning. It won't do that. It will directly go to the particular micropartition. It will fetch the data. So in that case, what will happen? We are saving our time. We will get the information within fraction of seconds. Even if you have lakhs of records in your table, okay. Even if you have lakhs of records in your table, but you are having that ID information, for example, 104 in only 1 micropartitions. Okay. So in such case also, even if you have thousands of micropartitions also, okay, this whenever you're writing some Snowflake query, guys, it will directly go to the particular micropartition. It will fetch the data. Because of whenever the data is getting segregated into micropartitions, okay, while doing that, it will store all the metadata information of all the micropartitions. What is that? The Snowflake stores all the metadata information of all the micropartitions, guys. Because of that, whenever you are searching for some data, it is already stored that metadata. Metadata means what, guys? Like what are the rows? metadata of this particular micropartition, for example. So I want to know metadata of particular micropartition, for example. Okay. So which means what? So what are the rows available, and what are the columns are available in this micropartition, and what is the values 2, 4, 3, 2, 3, 2, like these things. So all these things will be stored in Snowflake in the clustering metadata information. So that is why even if you have 10 lakh records in your table also, if you search for employee ID 104 guys, it will directly go to the particular micropartition. It will fetch the data. So that is why you are getting the data in fraction of seconds. Okay, fraction of seconds you're getting your data, guys, because of this micropartitions and this clustering metadata information, which is already stored in Snowflake. Okay, so that is called micropartitioning, guys. That is why this data got whenever the data loading into table, before that this data got segregated into multiple micropartitions in Snowflake. Okay, so this kind of structure we didn't see any databases, guys. So that is why it is very popular. So that's why I said it is having unique architecture. Okay, that's all about database storage layer, guys. Let's move on to query processing layer now. Query processing layer. If you can see here, okay, now we have stored our data. So now what we need to do? We need to see some information depends upon the client requirement, for example. Okay, so we need to run some queries. So where we can run the queries in Snowflake? In query processing layer, we can run the queries, right? So if you want to run some queries, I already told you. If you want to run some queries, what we need some compute power, right? Compute power. Without that, we cannot write any kind of queries. We cannot see any kind of data. Here, not in Snowflake, guys. In any database also, without compute power, we can't do anything. Okay. We need two things for sure: storage and compute. Storage is useful for us to store the data, and compute is gonna useful for us to run our queries to see our data. Okay. In Snowflake, what we can do in SQL or Snowflake, what we can do, we need to write the queries to see the data. If you want to write the queries, if you want to run those queries, we need some compute power. So that will be given by in the query processing layer. From this virtual warehouses, we will get the compute power, guys. In query processing layer, from the virtual warehouses, guys, we will get the compute power. So in Snowflake, by using these virtual warehouses, we can run our queries in query processing layer, guys. Okay, whatever the query if you want to run, we need to create these virtual warehouses, and okay, and also we need to provide some clusters. Clusters means, guys, these things you are able to see gear symbols, right? So gear symbols is nothing but clusters. So clusters is nothing but, guys, depends upon the clusters count, the performance of the particular virtual warehouse will improve. For example, in the virtual warehouse, we do have multiple sizes. See, these are the warehouses, guys. In the virtual warehouses, we have multiple sizes. XS, like our t-shirts. XS, small, medium, large, XL, 2XL, 3XL, 4XL. Okay. So here one means one cluster. For XS, one cluster will be available. For small, 2 clusters will be available. For medium, 4 clusters, 8 clusters, and 16 clusters. So depends upon the size, the cluster size is increasing. Which means what, guys? If you're working, if you're dealing with small kind of queries, simple queries, we can go extra small. That is enough. Even one cluster is enough, guys. Okay, but you're dealing with complex queries. Maybe you're writing such kind of big complex queries. In such cases, we need to increase the size of the warehouse. It may be a medium, it may be a large, maybe extra large. Depends upon the queries, guys. Depends upon the data load. Depends upon the data. Depends upon your query. We need to go for the bigger sizes. If you go for the bigger sizes, your query will run faster. Okay. If you have any simple normal queries, we can by using this simple small size warehouses, we can run our queries, guys. Okay, so here we have some option that so whenever we want, we can increase the size of the warehouse to make your queries run very faster. If you want to reduce the size, we can reduce the size as well. If there is any small kind of queries, okay. If there is a simple queries, we can also go with small size of warehouse to run our queries. Even if you want to go with a big queries also, we can go with the big sizes of warehouses, guys. So that is how these clusters will be useful for us to run our queries. So this where is this cluster is available in the virtual warehouse. In the virtual warehouse, this